Uh, Before I get into working with React, I want to say something about aspects of JavaScript that React requires you to know. So I said in the previous video that React, it will lean on existing aspects of JavaScript where possible instead of inventing new ways to do things. This is different than some other frameworks which will fill in gaps by introducing new syntax, APIs, etc. So React does introduce new syntax in the form of JSX, which I want to talk about. However, it just uses a ton of JavaScript. And so if you are also learning JavaScript at the same time, there is a bit of a burden for you to understand how some of these aspects of the language work. So what I thought I would do is just do a quick refresher or introduction, depending on whether you've seen these things before, to some of the ideas that I'm going to use over and over again in the code that I write and the code that you write for working with React. Okay, so the first concept that I want to talk about, let me just mention this. If you go in the React docs, they have some really good links to places to go and learning JavaScript. So if you need to learn JavaScript, they have a bunch of tutorials, ways of working, and they link to this reintroduction to JavaScript on MDN. You can't spend too much time learning JavaScript because JavaScript is continuing to evolve. So the JavaScript that you learned originally, you need to add more and more and more to it. Every time that I've taught this course, React is new because JavaScript is new. New features in JavaScript mean that they can do new things in React. So you need to invest heavily in learning your language, just like if you were going to be a carpenter, you'd need to learn how to use your tools really well. JavaScript is the tool that we're going to use. All right, so let's just jump into this. So one of the things that I'm going to talk about first of all is I'll mention lots of things in Ecmascript 6. So ES6 was a major release for JavaScript, and they introduced a whole bunch of things. So one of the things that I've been using all along is ES6 classes. So React originally used classes to write all of its components, and so as a result, you're going to see them when you look on the web. I'm going to teach functional components. In other words, I'm not going to use classes, I'm going to use functions, and I'll talk about the difference between them, but I want you to be aware of classes. So traditionally in JavaScript, like if we were going to write a polygon, we would say function polygon, and it takes height and width like this. And then if we wanted to add methods to the polygon, actually, let me switch my view here so you can see what I'm typing. We had a constructor function. So here's our constructor function in JavaScript, and I need to rename this. Bear with me for 1 second. Rename this to there. Okay. So we have a polygon, and we would say, this dot height equals height, this dot width equals width. And we could put methods, shared methods on the object that we're going to be working with by saying polygon.prototype.say name is equal to a function, and we could do whatever we want in here, but we would say, this dot height, and we would do, let height equals whatever. So let's just make ours look like theirs. And we would say console.log hi, and then this.name. And we would create one of these things. We would say let poly equals new polygon, and we would pass in whatever, the name, the width, the height, something like that. And we could say poly dot say name, something like that, right? So this is how we used to write object-oriented code inside of JavaScript pre Ecmascript 6. And here we have this new syntax. So we can transform this style of code, which is still correct JavaScript, we can transform it into something that looks like this. So we can use class. So we can say class polygon. We can rewrite our constructor as a constructor. So we can say that a polygon class has a constructor. And when you write code like this, what it's actually producing is the same thing as this. So it still produces the same style of classes that JavaScript had before, but it gives us this new syntax. So a lot of the things that get introduced in Ecmascript 6 and beyond, newer versions of JavaScript, are improved syntax as opposed to changing the underlying function of the language. It just makes it easier to do certain things. We can do methods. You can see here that this syntax is how I can define a property, which is a function that I can call. So instead of having to say name colon function, whatever, like I'm doing here, it's possible to just wrap it up all in one piece like this. And you can see that if I scroll down a little bit, it's possible to do inheritance. So I can have a class, and that class can extend another class. So it inherits all of the behaviors, all of the properties, and so on from the parent using inheritance. And here you can see that I'm doing that by calling the constructor of the parent. I'm using super as the first line inside my constructor in order to call this thing. So I'm not going to say a ton about this, except that why don't I write some code the way that we were talking about previously. So if I had a component, and a component takes in some value on the constructor, and it stores this dot value like this, and we have a render function, and the render function takes value and returns some transformed version of value. So let's say I'm going to return hello this dot value, like that. And component polygon is not defined. Function, oh, components. So if I was going to rewrite this in ES6, what I would do is I would say that I have a class called component, like that, and I have a constructor. The constructor takes in some value, and it stores the value on the instance. So hopefully this is looking familiar from lots of other languages where you've done similar things, C++, Java, etc., other object-oriented languages. And then I have a render method, and the render method, takes the data that's passed into me, and it returns some new version of it. So I have this older style prototype-based class, right? Prototype-based class. I have an ES6 class like this, right? A couple of different ways of focusing on this. So you'll see this a lot with the React documentation where they're working with classes. And if you need a refresher, my favorite site for reminding myself how these work is to go to, if you do a search for ES6 class example, there's a Google Chrome page that comes up, googlechrome.github.io samples classes ES6. And it's really nice. It just has a whole bunch of examples of doing all kinds of common things with classes. How do I do getters and setters? How do I do methods? How do I do inheritance? Simple things that you just need to go and look at the syntax and you get it. So something that's going to become relevant for the work we're going to do with React is that we're going to take this and write it in a functional pattern. So if you look at this code, like what is this code really doing? We're creating an instance of a class where if we were to use this, we would say, let component equals new component, and we pass in some value, 1, 2, 3, 4. And then when we want to render this, let rendered equals component.render. We do that. So you can see that our class-based approach has, two steps to it. I have to create the component. The component stores its state as a series of values on the instance, or these properties on the instance. And then we have a render method, which can take the current state of the object and it can return a representation of that I want to use in some format. So in a functional pattern, what I'm going to do is I'm going to collapse all this together. So essentially what I want to do is I want to take this render function and I'm going to write a function called component that takes in a value and it's going to return the rendered state of that value. So the new way that I would work with this is I would say let rendered equals component 1, 2, 3, 4, like that. Now, this is a simplification, but you're looking at a class-based way of doing this where I think about data as a series of objects, and objects contain state, and those objects can produce a rendered version of that state, so whatever that looks like, a string, or in the case of React, it's going to be a series of React elements, which we'll talk about later. And if I move to a more functional pattern, essentially what I've done is I've collapsed all of this down and I've turned it into a single function that takes in the data. So it's almost like a constructor, and it also produces the value, the rendered value that I want to get from it. So you're going to see both of these styles come up a lot in React, but React heavily favors this functional pattern, where you're doing something where, if you think about what a function is a machine for passing. I have data. I want to pass that data into a function, and I want to get an output. And I should be able to pass the same data into that function over and over and over again. And no matter what else is going on in my program, always get back the same value, or to be able to rely on that function to not have side effects, or in the language of functional programming, they'll talk about things being pure, where I'm not going to reach out and set a global variable, global variable equals value. I'm not going to store that in some global variable, or I'm not going to do something with the DOM, or I'm just going to take data and I'm going to run it through an algorithm. So maybe I take this data and I say value equals value plus 1. So I add 1 to it, and I need to get rid of this there. But so I take this, I have some operation that I run on it, and then I render that out. Okay. So this is the idea that we're going to be moving between. Okay, so let me just keep running through some different things. So another concept that's going to be big that you're going to see come up a lot is the idea of different ways of writing these functions. And you've probably seen a bunch of these or become used to doing some of them, but I have a function f. F takes in a and b, and it returns a plus b, like that. So there's lots of times where a function is being used to transform the arguments into some, it's essentially you want to be able to return some expression. And so what you're going to see a lot of people doing is you're going to see, instead of writing a function, they're going to write an arrow function. So they're going to say const, let's say g, is equal to a function. So I'm going to say, so I could do this. Let's just be clear. So I could say a and b return a plus b. So that is perfectly legitimate. I need a semicolon here because I have a function expression. That is legitimate. We can do that. But we can also change this around. So the first thing we can do is we can drop the function keyword. We don't need it. And instead of having the function keyword, I'm going to introduce a fat arrow. So instead of having to write the function here, I'm going to do a fat arrow. Now this can feel really clunky because you've got an equal sign here, you got an equal sign here, and when you're first getting used to reading this, it's going to seem odd. But what we've done is we still have our arguments. Our arguments are still there. They're wrapped in parentheses like we had a moment ago. And I'm now returning this expression, a plus b. So if I was going to do, let total equals a plus b, and I want to return total, if I was going to do something like that, then it's really important that I have a body. So you can see that I have wrapped, after my arrow function, I have these braces because I have a block of code that I want to execute. So sometimes you will see it written this way, and that's totally valid. However, you will also see that people will just get rid of the variables in here. Sometimes what they want to do is they just want to return this expression. So they want to be able to return this. So if all you're going to do, sorry, I can't type. If all you're going to do is return, then in this case, what I can do is I can get rid of the body, and I can move this up to the next line like this. And you'll see that I'm getting an error here from ESLint that says, I expected a body here, but I don't see one. And what I'm going to do is I'm just going to remove the return statement, like so. And it will mean the same thing. So this says g is equal to a function that takes two arguments, a and b, and it is going to return a plus b. So these arrow functions are really handy for writing inline short little expressions like this where I need to evaluate something. In React, you're going to see them all the time. There's another thing to be aware of with arrow functions, and that is if an arrow function ever returns, if it ever uses something like this, this.a, you have to be aware that an arrow function is going to bind to the value of this that existed when this function was built. So when this was created, whatever the value of this is right here, so if you think about this existing out here, like whatever the scope of this is, it's going to be implicitly bound inside of this expression here, which means that you have to be really careful in classes. Like when you're writing a class, you won't use arrow functions in here to do this, because if we do, well, the value of this is something that's very slippery in JavaScript, where this can refer to the instance, like here it refers to the instance, but this can also refer to the global. So like it could refer to window, etc., etc. So just be aware that there's an extra sort of hidden binding that happens between the current value of this and whatever this function is going to have. One of the things that goes away when we use function components is having to deal with this. So this is something that you end up having to deal with a lot when you're building class-based, traditional object-oriented style. And I'm going to ask you to move away from that. React is going to ask you to move away from that in favor of pure functions, which aren't going to be littered with so many problems with this. So if you aren't comfortable with arrow functions, you need to spend some time reading about them and get comfortable with them. So go to the docs, go to the MDN docs, and learn about how you use arrow functions and different ways we can work with them. You're going to see them a lot. Okay, so let's talk about another interesting thing that you'll see in React. So if I have an object, let's say I have a user, and a user has an ID, 1, 2, 3, 4, and they have a first name, Dave, and they have a last name, Humphrey, like that. Something that you're going to see happen a lot is you're going to see people using what's called they're going to use destructing. So let me just show you an example of it. So I'm going to say const fname is equal to user. You're going to see syntax like that. Or they will say const fname lname is equal to user. So what on earth does this mean? When I have an object like this, and it has a whole series of keys, ID, first name, last name, it's possible for me to reach in and pull this off. So let's just go back to the fname example. What I would have written before is I would have written something like this, fname equals user.fname. So those two lines are equivalent. I am taking user and I am almost like blowing it apart. I'm blowing it apart and I'm reaching in and I'm grabbing just the fname property and I'm assigning a variable to it like this. If a property doesn't exist, so let's say I did this, for example, const email equals user. That's going to fail, right? Like email isn't going to have a value because there isn't an email in here. So one of the things that you'll see people do is they will provide a default, default at google.com, whatever. So they will specify that this has a default value that needs to be used, that we're going to use when we're going through this if the object doesn't have it. We can do the same thing with arrays. So if I have an array, I have a list. Or let's do something. We were talking about latitude and longitude. So if you did lat, lon, Seneca. Yeah, so if we do Seneca College. Right, so we have, say we have the latitude and longitude for this. So let's say I have a coordinate is equal to the latitude and longitude for this. If I was wanting to pull out the latitude and longitude, I could write the following. So I could say let latitude equals coord at 0, let longitude equals coord at 1. But with destructuring, what I can also do is I can say let lat long is equal to coord. So meaning, reach into the array and get the first element and assign it to a variable called latitude. Reach in and get the second and assign it to something called coordinate. So you'll see lots and lots of places in React where we're going to do this. We're going to do this approach where we're going to pull data off of an object like this. So a common thing that you'll see happen, you'll have a function, and the function takes options. So you know how in JavaScript, function h, it's really common to pass in so if I said h, pass in a series of options. So I have something like ID is 8, name is foo, and is admin is true. I have a bunch of arguments that I want to combine together into an options object. So I send it in like this. So what do we typically do? So a lot of times your code will look like this. People will do options equals options or an empty object. So number one, in case somebody calls the function like this and they don't pass in an options object, then we're careful to construct the options object. And then they'll say something like const ID equals options.id, or we have some default value that we want to set, or we want to throw, whatever it is. And they go through and they say const name equals options.name, const is admin equals options.isAdmin. And so now they have all of the data, all of the the options that they need in order to work with this. So for us, let's look at another way we can do this. So something that you'll see people do is instead of writing it this way, they will instead do the following. They'll say const ID name is admin is equal to options, like that. So this is destructuring the, then log these ID name is admin, whatever. So I'm using this same technique like this, where we pull the username off like so, and I am extracting all of those values from the object and assigning them to their own individual values. Now there's another trick that people do, is instead of doing that here, they just do the destructuring, they do it up here in the argument list. So they do that. And that allows me to get rid of this. I don't need this line anymore. And now I have all of these particular parameters that have been set, all of these variables that have been set, but you'll see that they're wrapped inside of the object parenthesis. So it's hard to say, destructuring from arrays and from objects is very, very common. Extracting little pieces of data off of a larger whole when you're trying to work on this. Okay, what else should we talk about? Let's say something about immutable data. So if I give you code like this, s equals hello world, what happens if I say s dot to uppercase? Well, we know that this will take s and it will turn it into uppercase. So my question to you is, what is the value of s right here? Is s uppercase or is s the way that it was before? So the interesting thing about the way that strings work in JavaScript, for example, is that strings are immutable. In other words, once you create this string, you can't change it. And you might say to me, yes, Dave, I can change this. I can say s equals s plus, put a period on the end. And now I've changed it. But you didn't change it. What you did was you took the value of s, you concatenated another string onto the end of it, and then look what you did right here. You overwrote the original one. You replaced the original one. If I want to get the value of, if I want to make s equal to an uppercase string, I have to say s equals s dot to uppercase. So you have been doing immutable programming for a long time when you're working with something like strings. But in React, we're going to spend a lot of time where we create new instances instead of updating old instances. We take all the data from something and we put it into a new object. So let's just talk about this let's talk about, for example, with objects. So if I had, let user is equal to name, Dave, and ID is 7, something like that. So if I wanted to make changes to this object, it's very common for people to use what's called the spread operator to be able to get the existing value of it and modify new things. So as an example, instead of modifying this object, so obviously how would I modify this object? I could say user.name equals Dave Humphrey. So I can update all of the values that are on this object. That's not a problem, right? We just reach in and we make changes to it. But the difficulty that React has is React wants to manage the state of your application based on data. And so they're very interested in knowing when the data changes. And if you make changes deep inside of an object, it's difficult to efficiently figure out when things have changed. So they instead want you to replace whole objects when you need to do this. So as an example, consider this code. User is equal to user. Let's just start there. maybe I'll do it on one line. What on earth does that mean? That's very weird code. So what this says is it says take all of the data inside of the user object. So what is an object? An object is a set of key value pairs. You just have a whole bunch of key value pairs. And you can see that I have them, they're separated by commas. Key value, key value, key value. So when I say ... user like this, I'm saying take everything inside of the user object, which is different from what the user object is. So the user object is the reference to the object in memory. User is a reference to an object that exists in memory, and that object has these key value pairs. So what I'm doing here is I'm saying make a new object. So like consider if I wrote this, what does that code mean? This code says make the reference that user refers to equal to a new empty object. Well, instead of doing a new empty object, what if I say take all of the aspects of what was inside the original one and put them in here? Like what if I did that? Well, this is the same code twice, right? Like I'm now saying take all of the values and copy them in. But another way to do it is to say, take everything that is inside of the existing user object, ... user, like so, and put it in there. Okay, now what if I wanted to, so this is a way to clone an object. So just while we're doing this, let's do the same thing for an array. So if I had list equals 1, 2, 3, 4, like this, and if I wanted to clone that array, how do I do it? I say list equals, a new empty array. So that's an empty array. And now I could say list equals list ... list, like so. Or if I wanted to make a copy, I could also say let copy is equal to, so this is now a duplicate copy of the original array. So this technique that I'm showing you here works for objects, and it also works for arrays. And so it says, when I say ... I'm saying grab all of the internal contents of that and get a hold of that, as opposed to the reference to the array. List does not equal all of this. List equals the reference to an array that exists in memory. The in-memory aspect, the array that exists in memory, has all of these items in it, and I'm copying those across. Now I want you to consider what this code would mean. What if I said ID is equal to 9? What does that code mean? And what does it mean if I said comma 5? So when we copy things like this, when we take the value of something and we copy it, what we can do is we can copy it exactly as it is. This says take everything that is inside the user object and bring it forward into this new context. However, after I do that, I want to overwrite ID is equal to 9. So what I'm going to end up with, the new user would look like user is equal to ID is 9 and name is equal to Dave. This is what it would look like if you were to, look at the object. So it has overwritten parts of it, but copied the rest of it. Down here, same deal. So I have my list and I have the number 5 at the end. So this will produce 1, 2, 3, 4, 5. If I had said 0, comma, and then put list in the middle, it would give me 0, comma, 1, 2, 3, 4, 5. So you're just cloning the internal portions of an array, and that's going to be used for copying things, making new instances of existing data, copying data. So we're going to see this used a lot. So we're going to do object destructuring, stuff like this, where we pull values out of specific values out of an array or specific properties out of an object. And we're also going to do cloning, where we create new objects based on old objects. So take the key value pairs that are there, or take the elements in an array, and we'll work with those. Okay, so what else should we mention while we're talking about new things or things that you're going to see a lot of? So function J takes a name and I want to take it, let's say, I don't know, a name and an ID. And I want to return an object that has, I want to basically put these two things into an object. So I'm going to take two strings and I want to create an object. So let's call this create user. Create user object. Okay, so it's clear what it does. So if I was to call this, I would say let user equals create user object 10 Dave. Something like that. And here, like that, right? So I want to be able to get an object that's created by this. So I have a function, and this function is going to do the following. It's going to say, it's going to return a new empty object, and I'm going to say, give it an ID property, and the value of the ID property is going to be the ID that's passed to me. And the name is going to be the name that was passed to me. And so I'm going to return that back again. And so now down here I could say, you know, console.log user.name. So I would be able to access the ID and the name properties of this object. So a common thing that you're going to see in newer JavaScript and a lot in React code is that when the name and the value are the same, it's just going to be collapsed into one like this. So it's very common to see people write code that looks like this: return ID and name inside of an object like this. And when you first look at it, it's going to feel really weird because your object doesn't appear to have the right things. It doesn't seem to have the key value pairs. And if we were to rewrite this as an arrow function, it would look like this: const create user object is equal to a function that takes a ID and a name, and it returns an object. And the way you return an object from an arrow function is you just wrap it in parentheses like this. So we can get rid of the return. We can do that. So you'll see code that looks like this, and it's really dense. Like it's just a bunch of equal signs and brackets. And the first time you run into stuff like this, it's going to feel really weird. But whenever you see an object, remember, if you're inside of an object literal like this and you see ID, it really means ID. It means that, like this, when we're going through. Okay. So when we're looking at this, another thing you may see is you may see people including default values. So if I don't give a name, maybe we want to have the default name be equal to unknown, like so. So it's common to provide these default values in your function definitions when you're going through and working on this. Okay, so many things we could talk about. Let's talk about one or two more, and then you know, obviously, as you're working through this and you have questions about JavaScript, just come talk to me about them. If you have things you're worried about, you don't understand. I've had some really interesting conversations with people in the last few weeks who have been struggling with concepts that were taught in previous courses or, you know, didn't go into too much depth in previous classes, and they felt like they didn't understand some pieces of them. I want you to take responsibility for the pieces that you don't know. So if you come across code that you don't understand, you should write down some notes and say, you know what, I'm really struggling with this concept. I need to go and figure this concept out, as opposed to just continuing to bang your head against your computer every time you have to do it or read some code and you don't understand what you're doing. So if you need help, just come chat with me. Come talk to me on Teams or by email, and we can work through this stuff. Okay, so let's do another thing. So I have a list of numbers. List is equal to 1, 2, 3, 4, like so. And what I want to do is I want to produce a string. I want to produce like an array of, you know, $1, $2, etc. I want to produce this string like this. Okay, so I'm going to write a function, const to currency is equal to a it's equal to a function that takes in a set of numbers, or let's just say nums, like that. Takes in a set of numbers. And what I want to do is I want to return a new list based on the old list. So a pattern that you're going to see a lot is you're going to see people using, so when you work with array.prototype.map is equal to a function that we can call. And what it does, map lets you define a function and call a function on a whole series of elements in a list. So people will write code that looks like this. They'll say nums.map, and it takes a function. So a lot of times people will write this as another arrow function. So it takes a single number, and it's going to take that number and it's going to return a new string. So I'm going to write a template literal string that looks like this. I'm going to put the currency, and then I'm going to put the number like this. So a lot of this code ends up being pretty terse, pretty dense. And as you're learning it, you may struggle to unpack what's going on, because in one line of code, I have a lot of different pieces. Like there's a for loop in here. There's a couple of functions in here. There's string concatenation in here. Like there's a lot of different pieces happening here that can be tricky when you're trying to understand what's going on and make sense of it. So if you run into code like this that, you know, doesn't make sense and you're trying to sort it out, take your time with it. And again, ask lots of questions and try and come to terms with it. So I just wanted to, I'll pause there for this part of the discussion. And there's lots more pieces of JavaScript that we could discuss. I mean, I could and should teach an entire course just on JavaScript, like all the deep parts of JavaScript and understanding the language. But as we're using React, you're gonna pick up lots of new things or new techniques that you haven't maybe used so much before, and pieces of newer, more modern JavaScript that you can integrate into the code that you write. Okay, so I'm going to pause this conversation now. In the next video, I want to talk about the extension to JavaScript that React includes called JSX. So we'll pick up the conversation in the next video.